Hello everyone, this is Shamkura. I'm here to present my topic on the platform engineers hidden network challenge, especially to talk about the multicast in the cloud native environments. Traditionally, the multicast is proven to reduce the bandwidth consumption in the on-prem environments, but the major cloud providers, most of them don't natively support multicast. So I'm going to be talking about the pros and cons of multicast and some of the alternate options that could potentially be implemented within the cloud native environments. So when I say multicast, what exactly it means, it's replicating the same data to multiple recipients. So a sender sends the data and the same data is being received by the multiple end hosts. Typically, where this helps, if we consider unicast, it's one to one, right? Sender sends the packet, receiver gets it. So for that to happen, they have to establish a session initially. And if we assume hundreds or thousands of receivers, one sender, that single sender has to build hundred or thousands of TCP sessions with each one of them, which is CPU intensive. So you're literally wasting the resource of the sender just by establishing these sessions, which is inefficient. So the better approach is using multicast, where you one sender sends the packet to the multicast group, and whoever joins that group, the receivers, they start receiving the packets, and there is no session between the sender and receiver. Whoever joins the group, they get those packets, and if you leave, you're out of the stream. So you could consider the multicast as an example of probably a radio stream or a TV channel streaming, where the broadcaster broadcasts the channel, the programs on this channel, and who are like, if you tune into that channel, you start seeing the picture in your TV, and whoever joins the channel, they will be able to see the same thing at that given time. And same thing with the radio, like the radio broadcaster streams on a certain frequency, and if you tune the radio to that frequency, you start listening to sounds or whatever the broadcast is done. So it's the same concept, like the multicast, one sender streams data, and whoever joins the group, they start receiving the data. Though there's a dramatic efficiency gain, but implementing that in the large scale virtual environments has been complex and difficult, which is why I think it's still not yet natively supported in some of the major cloud providers. So, what are the critical barriers, right, that broke multicast? State explosion in software defined networks. When we talk about multicast, the elements that are in the network have to maintain a forwarding table, and it has to be consistent across the network infrastructure in the cloud. And as there is, if you have multiple resources or the receivers joining and leaving the group, there is a huge amount of calculations that happen. So this could stress out the control plane of the backend infrastructure. So that could be one reason that could potentially prevent multicast being implemented in this wide network of public cloud. Security, another consideration. Typically, the cloud native platforms, this strictly depend on the multi-tenancy, where the different clients or customer workloads run in the shared physical infrastructure in the backend, but they're typically separated. There is no leakage of data, or the resource don't get shared into the other customers' environment, but the multicast designed to be operated under one administrative control. So there could be a potential that the data could leak into the other tenants' environments. So that probably one reason that the multicast could potentially be not implemented. The other thing is the operational complexity and automation challenges. With unicast, you can define its static routing, but when it comes to multicast, it's dynamically changing behavior, which is hard to predict. And as I said, it potentially causes a lot of recalculations in the forwarding table and a lot of stress in the control plane. So that's another reason. The fourth one, performance degradation in the virtual environments. Theoretically, multicast reduces the bandwidth consumption, but but it comes with the complexity of implementation and there's the processing of multicast packets through the virtual environments could potentially be far reaching, or maybe it exceeds the bandwidth savings. And the fifth one is the architecture mismatch with the cloud native patterns. So the microservices, they emphasize loosely on the loose coupling and they express explicit service boundaries. But when it comes to multicast, it's implicit coupling between the publisher and the subscribers. Those are like the five constraints that could potentially has been restricting the multicast to be natively supported in the cloud. And how having the multicast restricted in this cloud, it could impact infrastructure automation. One would be the migration challenges. So many financial, data, telecommunication, media streaming services heavily rely on multicast for the efficient data distribution, as most of their models depend on one couple senders, multiple receivers. But when it needs to be when it needs to be brought into the cloud native, it changed, like the legacy application moving into the cloud changes the whole infrastructure architecture, because as it's not natively supported. So if you're moving from on-prem legacy app, which is a multicast based, into cloud, that's where, since there is no native support for multicast in the cloud, you would have to employ some alternate solutions. So which kind of becomes complex, and that could result in migration challenges. And infrastructure as code, right? Like Terraform and cloud formations, there is no direct resource natively supported, so you cannot directly implement using the declarative approach. Rather, you have to have some complex workarounds through custom scripts, and that kind of breaks the process the platform engineers rely on, like the consistent, repeatable code that we kind of rely on with the state files. That kind of probably gets lagged. So those could be two of the impacts the infrastructure automation can have with the missing multicast, native multicast support in cloud. Container orchestration complications. So Service discovery in Kubernetes typically depends on the DNS, which is like the point-to-point communication patterns. Applications that generally use multicast for dynamic service discovery, they must be modified to work with the Kubernetes service abstraction model. So that's one challenge, that if you're gonna go from legacy app to like the microservices, that could be a huge change that needs to be considered. Security policy gaps. You can apply security policies for pod-to-pod communications, but the Kubernetes security policies do not control the multicast traffic, and that could be a potential security gap that could be left. Pod life cycles, the pods lifecycle management, the pods could be created, destroyed pretty quickly, even before the multicast recalculations happen. So that could be one complication if you want to implement multicast within the Kubernetes in the cloud native environment. So does that mean like we cannot do multicast? I would say there are a couple approaches that could be employed, though a little complex and have their pros and cons. But there could be a few approaches that could be taken. One is at the application level itself, within the developers actually take that network layer into the application, like code the membership, the group membership management, the message delivery, and error handling within the application. And they actually maintain the whole communication from sender to receivers within the application, though it increases the complexity, but it does provide with an approach where you could generally migrate your applications into cloud, but the overhead of network now falls onto the developers. And also with the networking layer added into the application, there could be performance issues as well. The other approach that we can employ is creating overlay networks. So there are a couple vendors that do support overlay networks within the public cloud environments. So the one way is to build, let's say, you have a marketplace router that you can deploy, and you can build the GRE tunnels from the host and the receivers. I mean, from the sender and receivers to that cloud router, which can access a central point, and then build BGP between the end host to that centralized router. And then the sender sends the packets to the router, and You can configure like the PIM, which kind of manages the whole multicast protocol. That's one way that it can be achieved, though, as I said, it has its own complexity. But it is one way that you can take off that overhead from the application and bring it back into the network layer compared to what we discussed earlier about application level replication. There are a couple cloud native alternate approaches that could potentially be reviewed as well. Mainly the messaging services like Amazon SQS, Cloud Pub Sub. They provide reliable, scalable message delivery, and if properly planned and designed, potentially the cloud native approach could be avoided. The network approach could be avoided, and potentially the application will be can be built more of with the cloud native resources. And if there is an application like the content delivery networks, if the application relies on the content distribution rather than real time data, then every cloud provider provides supports CDN. So that could be one that could be employed. And there are like software defined solutions, like the industries now, the network industries coming up with some of the solutions that could potentially be supported in the cloud as well, like a marketplace solutions. So that could be one option that we could potentially see in the future. Okay, so though we have the workarounds, but it does have its own cons. And first one is the complex workaround. Like even if you try to do it overlay or apply it in the application, the lack of native multicast support forces the development teams to learn new things and try to inculcate into the application. The whole developer experience gets affected, and it might slow down the software lifecycle, like the software development lifecycle as well. Environment inconsistency. You might be having a legacy application that locally works fine, but with the alternate approach that we try to implement in the cloud, so there could be this huge disconnect between the application, the on-prem, to what it's working now in the cloud native, in the public cloud with alternate solutions that you implement. And also the testing and the legacy would differ a lot when it comes to the solution implemented in the cloud. So these are some of the challenges that we might come across if we implemented the alternate way of implementing the multicast in the cloud. And operational overhead and complexity. So monitoring complexity and capacity planning challenges and multiple communication patterns. So monitoring becomes complex with the multicast, because monitoring and troubleshooting actually, given you would be implementing different, rather than using a cloud native, now you'll be implementing multiple overlay networks, with implementing overlay network with the different vendor elements in it. So it'll be hard to figure out where the issue is, and also like monitoring different elements centrally, that becomes a huge problem. And capacity planning, given the multicast, if you implement in the application, it would be hard to know what's the usage, and the scaling becomes difficult if it is managed entirely within the application. So that's another challenge that could arise implementing the alternate solutions. So it typically affects in higher costs, right? Higher costs, incident resolution become longer, and there could be delays being missed, service disruptions, production issues. You could implement with alternate approaches, but there are complexities and there are its own cons that come along with it. As I mentioned, the future prospects and emerging technologies, SDN native multicast protocols. So the vendors, the networking vendors are probably going to be building something that could natively support in future within the cloud environments, or maybe something that could be not implemented across the wide area network in the cloud, but potentially limited to a certain scope for a specific purpose. That could be option that could be implemented. And with the advancement of some of the NICs, like the smart NICs and the data processing units, that could help potentially reduce the challenges that we see in the virtualized environments. That could potentially reduce the performance issues that multicast pose in the cloud environments. And maybe service mesh integrations like STA on console. There's been great advancements, and potentially that's one arena that could kind of have like multicast like functionality in future. One cloud native option that could be researched is serverless event-driven architectures, because I think with so many issues that we could come across with the alternate approaches like doing multicast within the application or doing the overlay networks, increases as introduces complexity. I think going with the cloud native approach or redesigning your applications to be more cloud native probably would be the going forward, and serverless driven architectures could be something that could be employed. And yeah, as I mentioned, you could the cloud native alternates is one option that could be employed. Sorry, the operational complexity and architectural constraints in the cloud environment, the total cost of ownership includes not just resource consumption but also operational overhead and development complexity. And the future of efficient group communication in cloud environments likely lies in solutions design specifically for software defined centrally controlled architecture rather than adaptations of traditional distribution protocols. That ends my topic. Thank you all for listening.